Hey everybody, happy Thursday. Hope you're doing all right. We're almost done with the song, but that's okay. Alrighty, so we got a couple things today. Hey Frog, nice to see you here. Happy Thursday. Hope you're doing well. So sorry I missed you on Tuesday. The internet was just nuts here. Like everything was up and down. Maybe it was just the other services, but it seemed like Comcast itself, like everything was being flaky on me. But apparently, if Google, their Google Cloud services were having issues that impacts a large chunk of the web there. So hopefully you had a chance to watch the recording from last year. Oh man, that was a long time ago. Wow. 2020 was rough. We're going to finish up talking about files here, and then I did want to go over a rubric for the final project as well that we've talked about. That's coming up. We've got less than a month to work on that one here. We've got Thanksgiving break all week next week, so there's no lab Monday, there's no lecture Tuesday, no lecture Thursday. So we'll pick up a lab on files on 11/29 after Thanksgiving. And oh goodness, I hope that goes well, because rates are not doing so hot here in Michigan. And if everyone goes to everybody's house for Thanksgiving, I'll be honest, I'm a little concerned. But I got my booster, so I'm feeling pretty good. I should be in pretty good shape. And, we wear our masks and we stay away from each other mostly, and life is pretty good doing our stuff in person there. So that's the plan. And again, if you're not comfortable, that's cool. You're welcome to do that remotely. I did get some bummer news about 2001, though. So for next semester, I know a couple of people had mentioned there were some conflicts with the lab time. I think one person had a stats class that was conflicting with the lecture time. And I thought they would override it. If I told them, hey, it's okay if you can't make it because attendance isn't required. Apparently that's not cool. I talked with my department chair, and he said, well, if it's listed as an in-person class, they don't do overrides because that's just the policy. Like even if I say attendance isn't required and I've got recordings, it's listed as an in-person class and they are not going to offer overrides for it, which is really sad. I'm sorry. So I was trying to talk to him to see if the format could be changed possibly, and that sounds like it's pulling teeth. So that is unlikely to happen. As long as there were other sections available, because the idea is they have a map of the way these courses are laid out and things that people take, but excuse me, people take them all different semesters, but we only offer 1501 in the fall and 2001 in the winter. So like it's a fall and winter 2-course pair. So sorry, I need some more coffee. So unless another similar like pairing where they only do a winter class is conflicting, they're not gonna work around that, which is really unfortunate. So my apologies. I thought that was something they would do, and I was very wrong. And apparently it was causing trouble. Really sorry about that. Don't think there's anything else I can do. I didn't seem like my chair was open to changing the format, given that it's already in the system. So I'm sorry. I hope there's a different scheduling option that'll work for you then. My apologies for all the hoops that didn't end up going through anyway. So we had a little chat in Discord about that earlier as well. So, all right, so we're going to finish up talking about files here. And we'll do a couple more examples, look at writing files and reading files, those sorts of things. And really what I'm interested in is how we can kind of pair this with the stuff we talked about with classes. And it looks like I forgot to post some quizzes here on classes and exceptions and modules. We're too far, and even lists and dictionaries, my goodness. I think we're too far back. I don't want to post a whole bunch of them. So we'll just do a quiz on files. And then we'll probably do one on inheritance and recursion, and then we'll call that good for the quizzes here in the section. So we'll keep going with our labs. We won't have a lab on plotting here, unfortunately. We just don't. There's no like meeting time after the fact for that. The lab on inheritance and recursion will be that'll be like the last lab here, then week 15 of the course. So we're getting close to finishing up with labs already. We're almost done with the quizzes. Don't forget about Gradebook. That is like a really good source of practice going through those exercises, and there are Xi labs that are built in, having you go through and make it do exactly what it wants you to do, letter for letter, capital for capital, space for space. It's quite particular, but that's a good practice to get into, being very specific and very deliberate about how we make our outputs. I'm still behind on grading those projects. My apologies. I should be able to get caught back up over Thanksgiving break. The break is all about Xi books for you, Trumpet Man. Yeah. I think I got all the midterms scored for you, right? Those should all have been in, and then our final project is what we'll be working on, focusing on next, now that the rest of the projects are out of the way. And again, I want to talk about a rubric for the final project as well, and we'll be able to go from there, okay? All right, so we got the Xi books here. Let's close out of our exceptions and module stuff, start a new project for files. Now, files were fun, right? Because we finally now have a way that we can have data persist and stay in between runs. So everything up to this point that we've done only worked with data in memory, right? Whether or not we were hard coding some data in to load into memory, or we were asking the user to input a bunch of stuff, but it essentially was only there in memory. And it was kind of a bummer. Like we spent a bunch of time writing that little Gradebook application, and then if I close Python, I lose all that information. So like that's the sort of thing that would be kind of helpful to have actually stick around after the fact. So to do that sort of thing, we need a particular format for how are we going to write the data to the file, and how are we going to read the data from the file. We briefly talked about binary file types. We're not going to get into that too much, especially not really a 1501 topic. Just know that you can do those sorts of things, but we're going to deal with the text-based formats. I think in general they're a little easier for us to wrap our heads around, and then I think that'll go relatively well. So let's actually go back, and I want to grab which was that Gradebook one we just did? Is that Lab 6, I want to say? Let me open that in the new window, see if I can have these side by side. I think that was Lab 6, right? Yeah, so we made this nice, pretty dictionary where you could add students, we could add grades, we could add assignments, that sort of thing here. So let me do all of this. I'm just going to copy it out, and we're going to put it over here in our files section, and I'm going to add a new option here. So I'm going to have a new option here for, we'll say 5 is save Gradebook to file here, and then maybe 6 will be quit, maybe. Actually, I need to add a load here in a second. So let's see. We'll do, maybe we'll make 7 quit, and then we'll have load be 6. Load Gradebook from file. So we'll be able to save the Gradebook, and we'll be able to load the Gradebook here for 6 and 7. So while choice is not 7, then, right, that was our quit choice here. If choice is 1, LF choice is 2, choice is 3, choice is 4. So LF, my choice, is equal to 5. So this one was our save Gradebook to file. So let's ask them for a file name. So first we'll get the file name. Is going to be an input of the name of the file to save the Gradebook to. Okay, and then we're going to open, right? You're going to open a file, you're going to read or write it, and you're going to close it. We're always going to do those 3 things. But then we saw, hey, because people forget to close files a lot, that can cause all sorts of trouble. There's that shortcut for us. We can use the with syntax. So we can say, all right, I want to say with open file name plus .txt, right? Because we want to add that extension in here. So they're just going to say like, CIS 1501, and we'll say, okay, let's make it a .txt file. Those are totally optional. It's not required at all to have a file extension. It just makes it easier for your operating system to know, oh, hey, this is a text file. I'll open it with my favorite text editor, that sort of thing. We'll call this as the file. Okay. Now what we need to do is we need to figure out how do we want to write the data to the file. And when we think about writing the data, we also need to think about at the same time, what is that going to look like for loading the data? Right? So I know that my dictionary has a key for student and an associated value of another dictionary. So that other dictionary then has the assignment name, points possible, and the assignment name score listed, right, with associated values of what did they earn and what was their score on it. So how do we want to write this out so that it's easy for us to load? So I think what might be easy for us to do is to use a funny character, right? Some kind of value that we're not expecting. I'm a big fan of like the tilde character. This little squiggly line, that's the shift accent above the tab key, or the pipe character, which is the shift of the backslash, is a pretty common one. Those are characters you don't generally expect to see, right, in some sort of input. So we can figure out which one we want to use, and then we're going to put that in between every value here. So if we think about, excuse me, man, I really need some more coffee here. All right. So, ooh, nice. I get dark mode word now. That's fancy. I think my Microsoft updated here. All right. Look at that. It knew it picked up my pen. How did it do that? That was super cool. All I did, like, it magnets to the side of the screen here, and like I just picked it up, and then it's like, oh, hey, you want to go in draw mode? So, if in a given line of our file here, then, right? So some line. What do we want to put here that we can read back out? So I'm thinking if we put the name of the student here, and then some kind of funky character like the tilde, then we can put the next value, right? The next value is going to be the key in the dictionary here. So then we'll have the assignment, and then it's either points possible or score, right? And then tilde, and then that value. And then we'll have name, tilde character, the assignment, and then this was the score, the tilde character, and then the value. All right, so for each one of these, if we include all of the information on every row, I'll be able to split this apart, and I can say, okay, hey, let me just split this into chunks, and I'll get the name as one chunk, and then I'll get the next key as another chunk, and then I'll get the value as another chunk. So I can go to my gradebook, key of the name, add a key of this value. Kind of what I'm thinking here. So if we put all of that in, then we should be able to regenerate that when we go to load it. So saving and loading always are going to go hand in hand, right? Because if you just save the data to a file, but you don't know how you're going to go load it after the fact, it really has done you no good. So you kind of have to think about both at the same time. So let's try that. So let's go. So we're going to say for key in gradebook, right? Which will be the, actually we should say like student name, right? So this is student in gradebook, or maybe we'll say student name in gradebook. We want to say for, and this is going to be, I don't know, it's either going to be the assignment points possible or assignment score. So I don't know, maybe we'll just call it key in gradebook, key of student name. This will give me all of the keys out. Now I need to get their associated values and write all of that here. So I'm going to take my file, and then we're going to write to it. We're going to write the student name. Let me do it like a little formatted string here, actually. It'll probably be easier. Write the student name, the tilde character. We're going to write the key from the dictionary, right, that's the dictionary associated with the student name, which will either be the assignment points possible or the assignment score. And we'll add a tilde here, and then we're going to add the, here we can even do this, key and value in dot, it's items, right? I think dot items. So we can write the key and the value all at once. Right, so this will give me, for each student name in the gradebook, every key in that dictionary. Let's go get the dictionary associated with that, give me the items, that pair of key and value, and for every key and value, let's write a line to that file here. Okay? And then because we're using this with, there's no need to close the file when we're done. So this does the opening and the closing as soon as this with block exits. So that should write the file. That's it. So then elif choice equals 6. We'll have to ask them, we need a file name as an input. Enter the name of the file to load. the gradebook from, right? And for now, we're actually not going to do anything else. I don't actually want to load it. I want to make sure that saving works first. But you know, we can load it. Why not? We'll load it here. So we're going to do the same idea here. I'm sorry. This is for reading mode. So we need to open this for writing. And we need to give it that flag for write mode. That's right. Forgot. We need the flag here. So if we want to write to our file, right, we need to give it that flag. Otherwise, we're in read-only mode, right? Default is the read mode here. So when we open our file, we need to give it that additional flag of I want writing mode. Okay? That way I can read and write. Or read or write, sorry. So now this time we're going to open. We don't need to give it the flag. This will be for reading mode. Now we're going to try and get out the lines here, right? So we can say the lines is equal to file dot read lines. This will read all of the lines out, right, to a list here. We can say for line in lines then. Now what I'm going to need here, right, I've got a gradebook already. So if I'm going to load it here, I actually need to clear the gradebook. So I'm going to take my gradebook, and I think there is a clear method here, right, that will empty the dictionary. So everything that used to be in it is gone. Right, so better hope you saved first. Then for every line in here, we're going to take our gradebook, and we're going to say key of, oh, sorry, so for that line, so first we need to get the values out. So this will be my values. It's equal to line.split. Remember, you have this cool split option here. We're going to split on that tilde character. Right, so then the first item at index 0 should be the name. The next item at index 1 should be the first key, and then the value at index 2 should be the value associated with that key. So we're going to take our gradebook. We're going to take a key of values index of 0, then key of values index of 1 equals values index of 2. Right, so this is the value associated with this key of the student name, which is a key in the first dictionary. I think, actually, before we do that, sorry, we need to take the gradebook and add a new dictionary first, because it's empty. Then we can go and add that key and this associated value. So this starts the empty dictionary, adds the value. Oh, goodness. Nope, that doesn't work. So if gradebook, or if, got to check first to see if it's empty. So if that, the name here, right, that's the values of 0. You know, let's give these better names. So say values, name, student name equals values of 0. And then the key is values of 1. And the value is values of 2. Okay. So then if my student name is not in my gradebook, then I want to add it. Okay, so if it doesn't already exist, add a new dictionary associated with this key. So add the student name, there we go. Then, after it's either been added new or it already existed, and take the student name, key of, add a new key of the key here, and the value associated with it should be the value. There we go. So that way, because we're going to get this name in here multiple times, right? If it's the very first time we got to that name, we'll add it as a new dictionary item. If it's not, then we can add the next associated value here with it. Okay? So I think that ought to do it here. Do we ever have a print? Yeah, print the gradebook was 4, right? Option 4 just prints it here. Okay, cool. So we got option 4 to print. Let's give it a try. So let's run this here. And let's print our gradebook. It should be empty, right? There's nothing in it. So let's add a student. Let me zoom this in, sorry. We'll add Eric. Great. Let's add another student. Let's add, we'll add my wife, Jasmine. We'll print. So now we're empty, right? We don't have any assignments. So let's go add an assignment here. Let's add, we'll call this lab. This wasn't even a lab. This is just exercise. Exercise 10. Sure, why not? And worth 10 points. Why not? Okay, and if I print my gradebook, now we see it has 10 points possible. We've each scored 0. So now let's go ahead and score the assignment. This was exercise 10. Uh-oh. I didn't... Oh, it was a capital E exercise 10. Shoot. I crashed it. Okay, sorry. Try again. Try again. Maybe we should not crash if that happens, right? Wouldn't that be nice here? What assignment do you want to score? And then for student in gradebook, I guess we should check to make sure it exists, right? If gradebook key of student, oh, I'm sorry, we're going to look for the assignment to score is not in the gradebook key of student. Print able to find that assignment with name of, do a little formatted string, our assignment to score here. And if that happens, then I guess this is a good chance to use that break, right? Stop the loop. Because if we didn't find it for one student, we're not going to find it for the rest of them here. That'll keep us from crashing here, I think. I like that. Okay, let's give that a run. Let's try that again. Stop and run. Yep, stop and run. All right, then add a student. We'll add Eric. We'll add a student. We'll add Jasmine. We'll add an assignment. This was exercise 10 for 10 points. Sure, why not? Print it out, make sure it looks okay. Yep. And let's score an assignment. So 3, and then exercise 10. Uh-oh, unable to find exercise 10. Oh, goodness, it's not even going to find that key. So we want plus points possible. Right? All right. So if we don't have the points possible, there. We're getting there. We're getting there. Let's run it again. Gotta clean this up a little bit here. All right. Add a student. Eric. Add a student. Jasmine. Add an assignment. Exercise 10. Oh, I gotta zoom it in again. Sorry. 10 points. All right. Score an assignment. Exercise 10. There we go. So Eric got 10 points. We'll say Jasmine got 10 points, and we'll print our gradebook. Great. So we see some in here. Let's add one more assignment here. Let's do final project. And say this is worth 25 points. And we'll just print our gradebook. Now we can see we've got the final project. We've got the exercise. Right, looking good so far. So now let's try and save it to a file. So let's call this 1501. So now I should see there's going to be a new file out here in my files directory. If I did this right, or did it not show up? Hang on. Why didn't it show up here? Come on. All right, let me go look in here, see if I can find it the hard way. So that's in Documents, in GitHub, CIS 1501, in Files. Oh, it is there. Okay, so it's just not showing in PyCharm. So we have a 1501.txt file. What we expected. If we open this one up, we see, uh-oh, it's all one big long line. Oh dear, I forgot to add my own new lines. Okay, so we messed it up. So when we write here, right, remember we need to add in our own, I think, or there was a right, is there a right line? Yeah, right. Nope, just right. So then we have to add in our own new line character. Well, that's annoying, but that's okay. So we'll do that. So save that and stop and start again. You know what? Actually, let me just edit this file. Here, let's see if we can do this here. Because this would be the format we want it to be in when we go and load it. So I just want to see if loading works too, right? This way we don't have to type it all in again, right? Which, see, we each have points possible and score, right, for each of those. Okay, well, we're going to save that change, right? And then let's see if we can load our gradebook from 1501. So now let's see if we can print the gradebook. We tried to load it, and do we get... Oh dear, it has the backslash n's in there itself. Well, that's ugly. Let's see. So we want to take the value of this one, and we're going to call strip. So strip will strip out any extra white space, which should be nice. So let's try that one more time. Run that. We're going to load it here. We're going to load from 1501. Print the gradebook. Hey, that looks a lot prettier here. So now we get my dictionary associated with each user without all those extra \n. Look at that. Okay, and now let's see if it'll save here, or let's go add another assignment here. Why not? So let's add test 1 for 15 points. Sure, let's print it out. We go ahead and added another thing here. Right, looking good so far. Let's go save it. 5. Let's save it over it in 1501. Oh, now it shows up in PyCharm, of course. So now I can open it here in PyCharm, and it looks like it printed it out properly now for us. Fantastic. So we're able to take this gradebook, write it to a file, and load it from a file. That's sort of the idea. So if we know what the particular format is, we're able to go and load it. So there's actually, it's relatively tricky to come up with a good format that you can use, like depending on what the data is, because you need to know what you're trying to load here. Right? So in our case, sure, it's just easy. We just keep on loading. We just keep on adding stuff to this dictionary. No problem here. It's not too big of a deal. Right, if we had some sort of like store inventory, sure, we could do that sort of thing. Now, the downside is our file's not all that efficient because I have to repeat the name key every time. The file's going to be larger than it needs to be. Hey, KMP, how you doing today? Happy Thursday. So I'm repeating a lot of this data here to make it easier for me to read, because if I didn't have the name, I'd have to go through and try some other things to figure out, well, what's actually in here. And there's lots of ways to do it. Like there's lots of different approaches to putting files, putting data into files. So maybe if I just write the name as one line and then I write all of the assignments after that, I can see whether or not it's a single value or a multiple value thing here. But I could check each line. That's a little bit annoying, but we could do that. So we could say, hey, read a line. And if the line split on my little tilde character, if it is length of 1, right, then it's a name. That's a student. If it's a length of 2, that's a key and value. Right, so I could check for each one. Every time I find one that has a length 1, it's a new student. Keep reading all the length 2s to get all their values, and then once I find a length 1, go back and add a new student. That can be a little bit tricky, but that might help the format be a little bit more efficient, right, in terms of what we're storing. So that's an option. You got lots of different ways. So there's no wrong way necessarily, but there's more efficient ways to do things. And really, storing text here like this is not the most efficient way anyway. This one's not too bad here, but generally with the binary format, you can be even more concise. But you need a very particular format to know what we're reading in and out in binary form. So that can be a little bit awkward. Okay. All right, let's see. Binary data. Yeah, this is lots of fun here. Yeah, I don't think we need to do any binary stuff right now. It's interesting, but it's can be funny to do. So I think we're in pretty good shape here. How you folks feeling about files? Hopefully this slightly more expanded example was a little bit more interesting here. Let me go commit this out to GitHub. And you know what? I'm going to be a good person here and set a good example. I'm going to go find my GitHub repository and cite my source here for where we took the starter code from Lab 6, because I copy-pasted a bunch of stuff. Yeah, I mean, it's not the worst thing in the world. It just it takes a lot of thought into what is the format going to look like for reading and writing to make sure I can do both here. So here's my file section. We're going to say adapted from, boom, look at that. I've cited my source here, life is good, right? We added in a couple features, but we essentially started with this one here, right? Or started from, maybe? Started from here. Look at that. And now we can commit to GitHub. 1501, fall. Here's file examples. Why? Okay, that's right. Yeah, we do get a bunch of that stuff. That's fine. Yep, commit and push. Yeah, files are a lot of fun. We can do some interesting things with them. So in terms of our course objectives. This is always fun to go back and look at, make sure we're hitting all the things we need to hit here. Right? Analyze requirements via UML use case and activity diagrams. We looked at this briefly early on. This idea is that we can kind of draw out the shape of what is the flow. The diamond operator is like that decision point, and you can either go this way if yes or this way if no. Just a way to put a nice little diagram of what is the logical flow. Use cases as a diagram is not all that interesting. I'm not the biggest fan of them, but it's saying, hey, this is what the program should do. So maybe we'll talk more about those later on. Compare the merits of alternate designs for programs intended to solve the same problem. Okay, maybe I've had too much coffee now. Is that possible? Maybe that's possible. So when we look at things, right, there's no necessarily wrong way, but what are the merits of alternate approaches? Right? What might be better for this? That sort of thing. Create our test cases based on pre and post conditions. Now, this is a really ugly, terrible old way of doing things. It's not the worst thing in the world, but a precondition says this must be in place before you do this thing, and the post condition says this is what it will look like when you're done with this thing. When we write our unit tests, we are doing this, but we're actually putting it into unit test code rather than having to run stuff in the main and say, okay, hey, let me enter some values. If I give it these values, right, that's the precondition. If you have these values, the postcondition is this is what you get back out. When we do our unit tests, we're doing this. We're creating those test cases. And we're actually going to do that in the final project as well. That'll be one of the requirements we'll talk about in a little bit here. You can decompose a complicated problem into simpler subproblems. That functional decomposition. How do we take a big problem, break it down into chunk by chunk by chunk by chunk to solve the little chunks? Can process programs using an integrated programming environment. We're using PyCharm, right? So I think we're doing that. We can systematically test and debug small programs. We're working on that. Can trace algorithms for correctness using simple test cases, right? If I give it this, do I get this back out? Right? That's what we're doing with our testing here. Drawing UML activity diagrams, sure, we can. I draw them with a little pen here. Visio is a great tool. We've got that available in the lab. We can use our debugger to assist in the process of identifying and removing defects from buggy algorithms. When we run it in debug mode and we see what the values are, we can see what happens. We can write pre and post conditions as part of the process of documenting software modules. We're going to write test cases. Right? Unit tests are the better way of doing this. Not that documentation is bad or wrong or anything, but I would like us to focus on code. Right? And if you can write the code, and you can write unit tests, that is our documentation here. The precondition, I'm arranging. Post-conditions, I'm asserting. Right? The act happens in the middle where we're actually testing here. So preconditions, all the stuff we arrange. Post-conditions, all the stuff we assert. You can write recursive procedures. We'll get there. We'll do our lab on recursion. You can write a small program in Python that solves a data science problem. It's a bit of a stretch to call our Powerball assignment a data science problem, but it's getting us there into, okay, how can we start doing all of these things and running simulations? I'm really big on simulating things because sometimes the math is really hard to figure things out. Now, the math behind Powerball is not the hardest thing in the world, right? We can calculate combinations to figure out how often you might win, and we could just generate the math and see what happens. But the real world isn't always exactly mathematical perfect randomness, right? Right? Sometimes people win even if we don't sell all 292 million tickets, that sort of thing. You know, it's just what happens. So if we can simulate the problem, we can put in our code and have it do it itself and do this random sampling here. It makes for a very interesting way to kind of tackle some of these problems. And we can design and implement functions with versatile behavior, use loops to perform repeated but not independent tasks, and model and process data items with multiple values. Look at that. So I think we've actually pretty much covered everything except recursion here in our course objectives. How you folks feeling so far? So we are near the end. We are not going to go deep on inheritance and recursion because, again, these are topics that will come back in 2001 if you continue on. But we're going to talk about them a little bit. And then the plotting and basic graphics are some fun. Plotting is really cool. There's a ton of things you can do with it. It's one of the best libraries in Python. This pyplot library, it's awesome. Yeah, KMP, I've been doing this for, oh my goodness, how many years now? 15 years, 16 years. Since I've been working since 2006, so 15 years. I've been working full time, and not necessarily a full-time programmer in every role, but particularly using scripting languages, this sorts of things. Not always Python, but that sort of approach. So I've got 15 years experience, and I've taught this class 5, 6, 7 times before, something like that. So I'm very familiar with these topics. So, you know, that's the sort of thing that comes with experience. And that's why we have the Xylabs for practice. That's why we have our labs for practice. That's why we have the projects for practice, right? The only way you're going to get better at this stuff is by doing it. I mean, reading, yes. I mean, you have to read the stuff. You have to probably listen to me. I'm not going to say I'm the most amazing person in the world. I'm giving you examples, and I try and give you examples that are not from Zybooks, so you can hear it from me, you can read it in Zybooks, and then you can try the labs, you can try my labs, you can try the projects to get you into writing code. That's the only way you're going to get better, is by writing code. I'm a huge believer in that you know, you have to do the thing hands-on to get better at it. So we're going to have lots of practice. So next semester, if you do continue on to 2001, and it works out with the schedule, but just keep in mind, and I'm still feeling terrible about it, I'm sorry, 2001 is only offered in winters. So if you have a conflict with another course, if it's possible to take a different section of that course or take that course at a different time, you're not going to be able to get back into 2001 until the next winter, which is really unfortunate, and I apologize for that. That's just kind of what enrollment is. You know, I think we only had 17 people in 1501. We'll probably only have like 15 people or so in 2001, because not everyone's going to continue on. We've got some friends who just need the first course for their other majors. So, yeah, KMP, it's good advice, right? Definitely. So, yeah, so we're kind of winding down. We'll hit on these lightly. We'll do our lab on inheritance recursion, tackle that last recursion point here. So essentially what happens is all of these map to something that we've done somewhere, and that way I can assess it. We didn't really draw the diagrams, so maybe we'll do one of these for our final project. That might be a good idea here. We can kind of show that flow of what it'll look like. We do need to add that in here. So we'll add in our little activity diagram as part of the final project, which is a good chance to help you think through the process as well, which is really fun. And then 1213 is coming up sooner than you might think. We'll get together on a little Zoom call, and you guys can present your final projects, where you just turn it on, hit run, and show us, hey, you can buy Powerball tickets, you can pick numbers, you can lose money. And the more you spend, right, the faster you're going to lose your money. Eventually, somebody does win, maybe, right? Like that's sort of the draw of the lottery, is that they can point to somebody wins eventually somewhere. And then generally, winning that much money for the people who typically play the lottery does not end up well for them, because they generally don't have good money management skills. And lots of people who win the lottery end up broke later on, which is insane that can happen here. But lottery winners going broke. I think there's a good article about it. Here you go, bankruptcy study. A third of lottery winners declare bankruptcy. A study by Wolfstrand. Oh, maybe that sounds funny, but sure. Bazinga? Oh, I don't know if that's a really good. All right, CNBC, that probably sounds a little bit more legit than whatever that is. Sure. Yeah, so it's unfortunate, right? This is it's not. It solves lots of problems. Yes, I don't want to pretend it doesn't solve problems, but if you don't manage money well, then it might not do you as many favors. And I guess 2/3 of them don't, so that's good. But 33% of winners is a lot. It's a lot of people. So kind of a little bit of a downer there. But so that's why we're going to pretend. We'll show them, hey, play as much as you want with our game. You're not going to lose real money, and maybe you can still get excited every now and then. So sure. I don't know. There's a lady I worked with at the help desk. She would buy 2 lottery tickets a day, and she jokingly, but I think half seriously would say that was her retirement plan. Is that over the next whenever she would finally be able to retire when she won the lottery, and she was just going to keep working until then. Otherwise, that was a little sad. But I think she was mostly joking about it. Maybe only half serious. I don't know. It's hard to tell sometimes with people. So, all right. Any other thoughts, questions, concerns? If not, we'll see you on the 29th for a lab where we'll practice files. So we got all Thanksgiving break off. If you don't want to work on the project, that's okay. If you do want to work on the project, I'll be around. Feel free to send me messages. Like, I'm not going anywhere. Don't have any big travel plans. We're just hanging out at home. Oh, dad joke. You got it, bae. You got it. That's much less conservative than your retirement plan, Trumpet Man. Oh dear. I don't know if I want to know now, Trumpet Man. Yeah, there's all sorts of good plans you're supposed to have, but things like that. Let's see, I got some dad jokes in here. I actually haven't gotten a lot. Okay, here we go. Oh, this one, this was a good one. So I was on a plane. There was an emergency, and someone shouted out, "Is there a doctor here?" And someone stands up and says, "Yes, I'm a doctor." And they say, "Oh, what's your specialty?" And he says, "Oh, I'm a doctor in mathematics." And the person says, why would you stand up? My friend is dying, and how are you going to help me? And he says, -1. That was a little dark. Yeah, I know Dr. Baugh likes to joke about, like, anytime anyone says, "Is there a doctor here?" He'll be like, "Yeah, I'm a doctor." And they say, "No, I wanted a medical doctor." He's like, why didn't you say that, or say physician?" Yeah, mutual funds, Trumpet Man, are generally the way people go investing in retirement, because thanks to our federal government and tax incentives and all sorts of stuff that happens, most decent-sized employers offer 401k retirement plans, that sort of thing, and you are incentivized through tax reductions in investing in those sorts of plans, and most of those plans invest really heavily into the stock market. Now, there's always options of bonds and things like that, but bonds typically don't have as good of return on investment. And we looked at some of that stuff with some of our earlier projects for fun, and we just took some random numbers, but you can actually look at them here. But interestingly enough, because there's tax incentives for people to invest in retirement plans that invest in the market, we are artificially inflating the demand for such things there. And if you have taken any class in economics, you know a little bit about the supply and demand curve, meaning if the supply is fixed, given there's only so many stocks out there to buy, right? I mean, every so often there are new companies and that sort of thing who go public, but generally if the supply is relatively fixed and demand increases, that means prices go up. And when prices go up, it means the value of your stocks that you have bought goes up. And that looks good for everybody, right? We seem to like when the market goes up. But weirdly, I'm a big fan of the Marketplace program on NPR, or American Public Media, with Kai Ryssdal. He's a great guy, as far as I can tell, at least. He will like to remind people that the stock market is not the economy. The two are, related, perhaps, but just because the stock market's doing well does not mean the economy's doing well. So just take that with a grain of salt. But not that I have all sorts of conspiracy theories, but it looks a little bit like a Ponzi scheme when you have all sorts of government incentives to invest in this market and increase demand. Oh, Lab 7, yeah, definitely do that. I don't think we did go over Lab 7 yet. Can do that one. Our classes and unit tests. Let's do that. Let's do a new project called Lab 7. Oh, maybe I started Lab 7. Says I already had something. Close out Lab 6. What did I get started with Lab 7? Oh goodness, where'd it go? Kill process. Terminate. All right, close out Lab 6. That one. Here's Lab 7. Oh yeah, I already had, oh, okay, so yeah, we had the very basics here of this and starting to look at some tests. That's what it was here. That's what we went over. So with Lab 7, what we needed to do was make a class for assignment with attributes for name, points possible, and points earned. Our init method would accept values for all three attributes. We're going to add get everything, get star functions for all the current values, set points that will accept a value, ensure it's between 0 and the points possible. If it's lower than 0, set it to 0. If it's higher, then set it to the points possible. All right, so let's start with name, points possible, and points earned. Oops, this one here. We have name, we have self dot points possible, and self dot points earned. Remember, good practice is to mark all of these with that underscore to indicate that it's a private value. You shouldn't touch it directly. Right? There should be no direct access to our private attributes. Again, Python's trusty. We're going to assume you're going to do the right thing, but it's not necessarily required, but that's okay. So then a get method is the public function that gives you access to that value. Right? And then I'll define a get points possible. Given self will return self dot points possible. And a get points earned. Given self, right, will return our self dot points earned. Okay, so that's our three attributes. That's our init method, accepting values for all of them. Our get functions. Now we need a set points earned function, which accepts a value for points earned. We'll have a defined set points earned, given self and points earned. Now we need to check if the points earned was less than 0, our self.points earned was going to be 0. Else if, or elif, if the points earned was greater than the self.points possible, then our self.points earned was going to be self.points possible. Right, set them to the max. So we're not allowing anything extra. If it's not too low and it's not too high, my points earned can be the points earned you give me. Right, so this is the points earned argument here we're going to set. Now, since we have all this logic here, we should do the same thing in the init method. Right? Just because you gave it to me here doesn't mean I should ignore any of this. So instead of copy pasting, we just call our method. We can say self.setPointsEarned given the points earned. So we'll call our own method inside of here. I have to sneeze, maybe. Woo! Woo! Sorry about that. I missed the mute button. Hopefully that wasn't too loud. Whew. Oh, man. Okay, so that's our set points earned method here. That's our function here. And then we need a get letter grade, which returns the letter grade based on the percentage score. So we'll have a, we'll just put it up here with the get letter grade given self. Now we need to figure out what our score was. So our score is going to be the self.points earned divided by self.points possible. Right? That'll be our percentage score here. We will call that percentage. Okay, and then we can say if our percentage is greater than or equal to 93, you return an A. Elif, if my percentage is, or percentage, come on, type ahead. Percentage is greater than or equal to 90, we can return an A minus. Right? Elif here. There we go. We just keep on working our way down, right? B plus, B, B minus, C plus, C, C minus, D plus, D, F. Is there a D minus? I don't remember if there's a D minus or not. But that's fine. We don't need to worry too much about it. So just keep on adjusting these then. So then 87 is going to be a B plus. A greater than 83 will be a B. Greater than 80 will be a B minus. Greater than 77, right? C plus. I feel like we've done one of these before. 73 is going to be a C. 70 will be a C minus. 67 will be the D plus. 63 was going to be a D. And else then, if it's not one of those, just our else, we're going to return an F. And actually these are wrong here because this is a single percentage here, so these should all be decimal places, right? Right, because I have your points earned divided by the points possible will be a number between 0 and 1, so that would have been a big problem here. Okay, So that's our get letter grade. So now what we need to do is we need to test it. Right? The idea is we're going to test it here to make sure we have 100% code coverage. So every possible letter score and all 3 possible outcomes from set points. Or if you call set points and you never give it a value that's less than 0, this line of code will never run. So in our test, we want to ensure if I call set points and I give it a value that's less than 0, this line of code runs. So code coverage is all about the lines of code that run while we're testing. So we're going to test main. We're going to test that init. So we'll have an expected name. We'll have an expected total or points possible. And we'll have an expected score or something like that. So we'll say like, I don't know, 10 out of 10. Sure. So expected name, the points possible. Oh goodness, which order did it go in? Points possible, points earned. Points possible, points earned. Sure, points earned. And points earned, give all 3 of those to the init method, and then we'll have an actual points possible, my assignment, get points possible, and an actual points earned is my assignment, get points earned. Right? So this, we're arranging, this is all the things we need to give it. Act, we're calling the code, and then we're checking, did we get back what we got, right? Get those values out, and then we can assert. Self.assert equal our expected points possible and the actual points possible. Right, do that again with the next one. Points earned, actual points earned. Let me run this test. So this one's not all that interesting, but it's going to make sure we at least did things correctly in our init method. We get all the values out, and we can get them back. So that one passes, right? Life is good here. So now we're going to test. So I do know that this one here tested this particular branch of points earned because it was not greater than the max. So I know this one already ran, right? So I need to have a less than 0 and a more than max test, right? Because I know the init method did that, so I'm going to have another test set points earned, we'll say negative, right? So we're going to do essentially the same thing, but we don't need all these values here. I'm going to copy paste. So I don't really care about the name because we're not going to check the name again. It's not a big deal for us, right? I don't really care what the name is, so I can just give it just like an empty string. As long as I'm giving it something, it's not going to care. But now I do need an expected points possible and a points earned. So I don't actually care about the points possible again. So I'm just going to give it a regular points possible. And then I'm going to give it something. This is my points earned. You know what? Actually, no, we'll leave that as expected points earned. It should be 0 if I give it a negative value. Yeah, so points possible, we don't even care, actually. So that's fine. And then we don't need to get name. We don't need to get the points possible. We're just going to get the points earned and check that. So if I give it a -1 points earned, I should expect it to be 0. Right? And now this one, we'll copy paste. And we're going to have this is earned more than possible. So if I give it more than the points possible, it should stop at points possible. So if I give it like 20, right, it should stop at 10. Let me run these tests. We'll, let me go up here. I can just run them all. There's a little run button here. We'll run all of our tests. And they all passed. Right, so now I should have a good feeling that I know this line of code ran, this line of code ran, this line of code ran. Again, there's tools you can get. There might be a free one for Python. I haven't found a decent one. Usually you can buy those sorts of tools, or like the PyCharm, the professional version, I believe does something like that. You know, maybe I can Google that real quick. Let's see. PyCharm code coverage measure. I don't know if it does that. Aha, look at that. I feel like that's probably not in the free version here. Yeah, let's see. What did we do here? Help from their version. Generally, that's the sort of thing you end up paying for, and it's not, yeah, professional. So if you get the professional version, right, then they will be able to measure this for you, which makes sense, right? So they give you the free version, which is fantastic, and then their professional version has cool tools and things that you might actually care about, right, in more of an enterprise environment. So sure, but we're not going to pay for this, so we're just going to kind of eyeball it and say, okay, I know I'll be getting into each one of these here, right? To do the same thing for get letter grade, then I'm not going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tests. That sounds like it's going to be a little tedious here, right? But let's do one. How about that? So we'll say define test get letter grade A. We need to arrange, we need to act, we need to assert. So with a 10 out of 10 here, this is our expected earned. If we get a 10 out of 10, then we want to get our letter grade. So an expected letter grade should be an A. Right, this is points earned. Points earned. Okay, so then our expected letter grade will be get letter grade. And we'll say our expected letter grade is the actual letter grade. Right? Do they match? So if I get a 10 out of 10, do I get an A? Let's test it. Okay, life is good so far. So again, we could, sure, we'll do maybe one more here. Let's try, how about a C+? C+. So a C+ then should be out of 100 if I earned 78, right? Should get a C+ back out. All right, we'll run that test. Okay, and that one passes. So again, we would do that for each one of them to get 100% code coverage. But I'm not going to, if that's okay with you, I'm going to skip past that. All right, so this is lab 7. Here, let me commit and push that. All right, then we need to talk about the final project rubric, if you're still curious, here, and assign some points. So, where'd it go? Where'd it go? Where'd it go? Where'd it go? There it is. Okay, yeah, no problem, KMP. Happy to go over those. And again, that's not the only way to go. Oh, goodness. Did I lose my internet? I got some drop. Okay, we're back. We're back, friends. We are back. Don't you worry. All right, so final project. We need to add in here. So here, let me edit the description real quick because we need to have this here. So let's do this here. Come on. Come on, Canvas. All right. Also, did I need to give you a final project in the GitHub Classroom? I forget to give you a link? Oh my goodness. I did not. Oh my goodness. Friends, I'm so sorry. So this is CIS 1501, fall 2021, final project. Great. This is Python template. Now we don't need an editor. Feedback pull requests. Fantastic. All right, so first, we're going to submit a couple things. So we're going to please submit the URL to your feedback pull request, a UML activity diagram showing the workflow of the program. Right, and we'll talk more about that, but that's the idea. Like, we start here, and then if we're going to prompt them for something, and they enter this value, we go here, do this. If they enter this value, we go here and do this. We sketched them out briefly earlier on. We can spend some time in lab and take a peek at how we might do it in Visio if you want. There's free tools online, which are probably easier to use than, I mean, maybe not easier to use, but easier to get to or have access to than Visio, because Visio is generally an expensive tool. So I think it's like Draw.io, I think is the free one a lot of people use. So we're going to do that. The UML activity diagram. Okay. And we also to include unit tests for the Powerball ticket class. Ensure the get winnings method or function works as expected. 100% code coverage. So this idea here, right, that when you can get your winnings out, if you know what the values are for the tickets here. So for our bounds checking, so when we check with no repeats, then we're going to have to raise an exception. The values are invalid. Right, so when they pick their own numbers, if they give me values that have repeats, or if they're out of bounds, we need to raise an exception. That's the way that my class communicates to whoever else is using this code that they did a bad thing. I'm in an invalid state, and you can't use me as a Powerball ticket in this way, because if you have repeats, like if you pick 11111 and there's a single 1 value in there, I'm probably going to say, oh, hey, you have 5 white matches, you just won $1 million. And no, that doesn't work like that, because then you'd have a 1 in 69 chance of winning $1 million. And obviously, they're not going to let us do that, right? The lottery is not going to lose money. Otherwise, the government wouldn't run the lottery, right? They don't give money away for free. Go figure. I mean, overall, they don't give money away for free. They have other tax policies and that sort of thing that essentially give money to some people, but and they spend more money than they make. But okay, I'm just getting depressed now, but that's okay. Oh man, that's sad. Okay, so our unit tests, right? So then we'll upload the website URL and a file upload here for the Visio diagram. Okay, so we'll do both URL, I don't know, text. Sure, we'll have some options. You should be able to enter a bunch of stuff here. Should be okay. And we should be in good shape here. Yellow. What's up, I am? All right, so our rubric here then. So we're going to have, this is our final project. You know what, let's go big on this here. So let's do, this is our UML activity diagram. We're going to say that's 5 points. Oh shoot, I wanted that one up above. That's okay. And we'll use this rubric for grading. So then the first one here is the Powerball ticket class. Right, it has private attributes, public methods. Right, it's good overall design here. All right, I'm feeling bad. I'm going to move those around because that's silly. Oops, nope. I have to cut that one out. Update. Here we go. Put this one back. Okay. And then our Powerball ticket. Powerball ticket class. Get winnings function accepts an instance of a winning ticket to compare itself with. And works, right? So points for doing it and that it actually works here. The Powerball ticket class unit tests, 100% code coverage. Right, and the idea here was focus on get winnings, test all the win levels, right? And then 5 more points for the Powerball simulator. Allows people to buy individual or random tickets, tracks total spent, total won, and net loss, runs until they are bored. Okay, actually, let me put that in the long description here, right? Powerball simulator, unit tests, 100% code coverage, the init methods for random or picked number. So in the init method, right, we can have optional parameters. So if you give me values, great. If you don't give me values, right, as they're optional, then that's fine. Right? We can either do a random if you don't give me values, or we'll take the numbers you give me if you want to pick them here, and then raises exception if picked values are invalid. Okay, so the human activity diagram shows workflow for the simulator. Okay, we're going to show, okay, what are they prompted with? What choices do they get to make here? And what happens? How that flow works in there, including calls to Powerball ticket class. Right? How are we going to use the sim shows workflow for simulator? There we go. Okay, so we'll go through some of that. Don't worry. So we got the rubrics. So that's your 25 points here. That make sense? Practice. It takes practice to be a good engineer. Lots of practice. Okay, any other thoughts, questions, concerns? If not, I hope you folks have a wonderful Thanksgiving break. Make sure you stay safe. And I will see you for lab the Monday after break. All right, I think that sounds good. Let me put on my ending screen here, see if there's anyone around. We can go raid for funsies. See if anyone's online. Where is it? Here we go. My goodness, no one's online. Why do I not have any friends online? Let's see. Let me check one more place here. Rocketology's on. If you want to do rockets, art, but that's not a safe for work art, unfortunately. Do ceramics. Maybe? I think we've done that one before. News. Yeah. There's a couple choices here. Yeah, that's all right. I think we've rated all those people before. We don't need to do it again. So we'll just call it a day. Folks, take care. Let me know how I can do to help.